Hi Spring fans, welcome to another installment of Spring Tips. In last week's installment, we looked at the Spring Authorization Server, your one-stop shop for building authorization-centric secured services and microservices and systems using OAuth. Now, we did the happy path. We looked at an in-memory authorization server with the tiniest fraction of code. We just created a couple of users. Then we looked at how to create an API using the resource server support. And we looked at how to create an API gateway, which acted as an OAuth client. All of this in memory, it worked great, okay? Really simple flow. Hopefully it was easy enough to understand. I tried to keep it short and sweet because goodness knows security can be kind of mind-numbing if you're not completely familiar with it. Certainly, I don't purport to be an expert at it. I do know a thing or two now after having, banged my head against the wall for 15 plus odd years trying to understand the domain. Thank goodness for Spring Security because I've been secure all those years, even if I didn't understand why I was secure. That's the benefit of a good framework is that you can just trust the team has you covered, and then as you get more familiar and more confident, you can start manipulating the levers and the knobs and dialing things around to get it to the point where you want. But that said, I do want to start customizing our authorization server a little bit. And I do want to start integrating new kinds of clients, not just OAuth HTTP clients. So in today's installment, we're going to look at two different kinds of clients. Static JavaScript-based applications, how do they talk to our OAuth authorization server? And also a messaging client, that is to say, something running in the background in a back office sort of asynchronous, headless, non-HTTP scenario. Let's dive right in. First things first. Let's go ahead and improve our application from last week. Last week, I suggested that we could just have a service to which we connect through the OAuth client, which is acting as our gateway, and we could use the gateway to then proxy both the API and some sort of static website hosted on a CDN. You know what? I think it's time to actually build that static website. Now, I'm not going to write JavaScript on this channel. I like you too much. We're going to go ahead and just bring that in. So last week, we talked about the gateway. The gateway is acting as an OAuth client. It's going to take our tokens, and if it can't find the request in the token, it'll initiate the OAuth dance, essentially redirecting us to the authorization server, giving us a chance to log in, and then redirecting us back to the client with the token in tow, allowing us to then make requests to whatever we want, right? It'll establish a session on the client with the current OAuth session, right? An OAuth token in session. So when we make requests, we can grab that token and use it to make calls to their via the REST client as an authorization header, or we could pass it on through Spring Cloud Gateway, which is acting as a proxy using the token relay filter and so on. And I suggested that we can have an API and a static website, a static sort of CDN-hosted JavaScript app, and then proxy both via the same gateway, and thus spare ourselves from having to establish that OAuth connection in the JavaScript code itself. You know what? It's time to make good on that. Let's go ahead and revisit our code. First, let's make our API a little bit more useful. We're going to actually add an API of some sort, right? So we're going to go to the resource server, right? That's the actual API itself. We'll go here, go to the code, go to the Java, and let's create a few interesting endpoints. Let's, first of all, refactor this. I don't want the greetings stuff anymore. Let's get rid of all that. Okay, so we have a public static void main, nothing else. And we're going to create a simple endpoint to return information about us. So basically, imagine a UI. It says, hello, whatever, Josh or Jaylong, or in this case, 1, which is the user that we created, 1 or 2, right? So we'll create a simple controller. We're going to create a simple controller called the me controller, okay? Not a very special one, just simple example. And we'll add that here. Okay, there's our controller. It's just a simple HTTP endpoint that when you go to /me, it returns the name of the current authenticated user, which is only going to work if there's an authenticated user. Well, thankfully, this is an OAuth client. If there is no authenticated user, we'll never be able to get to this endpoint because the gateway will see that we have no authenticated user. It'll redirect to the authorization server, forcing us to authenticate. Now, for our next example, let's add some sample data. So we're going to actually make this a real application, and I'm going to have some data and a message queue. So for that to work, we're going to need, RabbitMQ and Postgres, I suspect. So let's create a Docker Compose file. I'm going to put this Docker Compose file here at the root of the program, of the root of the system, paste it in there. Okay, so we've established Postgres, username, password, database name are all Postgres for simplicity. And we've got RabbitMQ with the management console. Username is user, password is password. I've exposed all the requisite ports so that they're available not just to internal IPs, but also external as well. All right, so now we're going to create a simple application that talks to both Postgres and to RabbitMQ. So we need to change the dependencies now on the resource server. Had we originated this program with RabbitMQ and Postgres in mind, we would have just selected these things on the Spring initializer. But such as life, it's fine. We just add it manually. I've just added a number of different dependencies, including support for RabbitMQ, AMQP, the protocol, JDBC and the Spring Data module for JDBC, Spring integration support for AMQP, Spring integration support for HTTP, and the Spring integration support for JDBC. These, I'm not sure if we actually need them, frankly, but it's fine. And then we got Postgres, Rabbit test, and Spring integration test. And then the same dependencies that we had last week, which is just the regular OAuth 2 resource service support, and the Spring Boot Starter web support, and the test support. Now, again, in plain fact, I think Spring integration HTTP probably brings in the bits where we need from Spring Boot Starter web, but it's fine. Just leave that all there, okay? So now with that, we need to configure our application to talk to a SQL database. So Spring data source username is Postgres, password Postgres, and URL is Postgres. We also want to initialize the application with any schema that's required, so Spring SQL init always. And we also want to connect to RabbitMQ, so Spring RabbitMQ username equals the user, and the password is password. I'm really good with names and also with credentials. All right, so there's our application, our resource server. We're going to tell it to validate any tokens it gets with localhost 8080. That's our authorization server. Now, we're going to build a simple data-centric application. Nothing fancy here. But, of course, if we want data, we need a database, and we need to initialize some schema. So I'll create a file here, schema.sql, and then we're going to create some sample data, all right? So we're going to initialize the schema by deleting it and then just inserting a bunch of records into the schema, into the table, which is called customer, which has 3 columns, ID, name, and email, all right? But now we need to create a Java representation of that data. All right, so now we have our repository, our interface, and our entity. This is a Spring Data module, Spring Data interface. Now let's go visit the OAuth client. The OAuth client, of course, in this case, is our gateway, the thing that's intercepting the request. So we go to the client application, and we're going to refactor this gateway to know about both our existing API, which we're going to route with a little bit of a path rewrite magic. We're going to say every request to /API/* gets sent to the API and port 8081, and then everything else gets sent to the JavaScript, which we haven't yet looked at, but we will just very soon. All right, so the API prefix is /API. All requests to API prefix / so wildcard, are considered, they get passed to the token relay filter, which means that we won't let any request go through without a valid OAuth token. This will initiate the OAuth dance, sending us to the auth server, and then redirecting back here with the token in tow. Everything for API prefix / gets rewritten as just /**. So basically, if you send a request to API /foo, then this will rewrite it as just /foo, no API. Okay, so it'll go to the downstream service looking like it was making a request to just /foo, even though the client will have sent it to /API /foo. And that's on port 8081 that we're proxying. Everything else goes to the static JavaScript app, which we're going to start up in just a second here on port 8020. We don't need CSRF tokens here because we're building a single page app. So let's disable that support for now. Okay, so we've got the gateway configured correctly, and we've got the auth server and the resource server. Let's go ahead and run everything. Close all tabs. Server, start that up. Remember, the user is 1 and the password is PW, and the user is 2 and the password is PW, so that's the 1, I'll call it. Resource server, let's go ahead and restart this. Okay, now we need to go to the resource server, and now we need to go to the gateway, which is the OAuth client application, and restart that. All right, we've got everything up and running, but we don't have our JavaScript. I'm going to go ahead and just copy and paste that whole thing because, yeah, JavaScript. So, all right. Behind the scenes here, we've got a new folder called static. Pretty straightforward. It's a HTML5 page. It's called Spring CRM. Some very basic CSS and some JavaScript. And the JavaScript is making requests to the /, right? /API /customers, /API /me. And there's another endpoint, which we'll introduce later, called email, okay? And it's going to display data by getting all the data from the customer's endpoint and just populating a table and allowing you to send an email to those users in each row, okay? But otherwise, it's 91 pages. It's not React or Angular or whatever. It's just a regular JavaScript page. And I've got a little shell script here to run it using Python, okay? So it's on port 8020. All right, let's try everything out. 127.0.0.1, 8082. All right, it's saying, hey, you're trying to go to the gateway. You're not authenticated. This is an incognito browser session. So we'll enter the username, which is 1, and the password, which is PW. It's asking, hey, this client acting on your behalf, which is, the browser-based client, but you could have multiple clients, one for iPhone, one for Android, one for the browser, one for whatever, is asking for permission to use the user.read scope or authority. Say approve. There we go. We redirected and we got the data. See, it's listing all the customers and their IDs, and we've got a button here. We haven't clicked on it yet, but we have it. And you can see it's able to get that information by calling the me endpoint, and it couldn't call the me endpoint unless there was a session that had a token in it. So basically, this browser is running on port 80, this browser client, this JavaScript, is running on port 8020. We're hitting the gateway on port 8082. It's proxying to 8020 to get the JavaScript, and it's proxying to 8081 for the Java API from 8082. So all the two things that we need, this JavaScript and the API, are on the same host and port. That gateway code, the gateway code running on port 8082, incepted our request. It saw that we didn't have a valid token. It forced us to reroute. We got redirected back, and now there's a session on the gateway with a current authenticated OAuth user. We can send requests through the gateway to the backend JavaScript code and to the backend API from this gateway. So we don't have to manage that. There's no logic in this JavaScript code here to deal with tokens. We don't need to, because as far as it's concerned, we're making a request within the browser to a URL for which there's a session, and that's being communicated via the cookie, which is all automatic, right? I'm using window.fetch here, nothing special here, and it's all just being done for me. So I get the best of both worlds. I get very simple JavaScript, and I don't have to worry about OAuth, and yet I also have OAuth. It's not like I'm making requests. I couldn't even get to the JavaScript app without OAuth. Let's put it that way. Okay, so now we have a simple client. This is a JavaScript client, right? Makes sense. So last week we looked at how to make a call to an API and have it authenticated by passing it through this gateway, which is nice because we are able to have and centralize all the OAuth logic in a single place in our application, the gateway. And here too, that gateway is coming in real clutch. We're able to just make short work of integrating an HTML5 application. Now, what about a messaging client? What if we want to make a call to another service that's running via some sort of asynchronous message queue, RabbitMQ, for example? Well, if we send a request and that thing gets sent over RabbitMQ to some other worker process, that worker process is going to want to make sure that that worker process is going to want to make sure that request it's been given, it should and has the need to execute. That is to say, we don't want clients that have no rights to make that request making those requests. So we want the processor to be able to validate that the request is coming from somebody that we trust. And we can only know that for sure by validating that the JOT token that's in the request, in the message of the request, is a valid one by talking to the OAuth server. This is very much the same thing as we're doing here in the resource server. Remember, the resource server is an OAuth client that has a simple filter in the web that looks at the incoming HTTP request and it says, hey, I don't see a valid token. This request is rejected, denied, right? We're going to re-implement that using some of the atoms that make up the HTTP analog in the messaging world, okay, using some key SPIs there. So first things first, let's add that email controller to our API, to our resource server, so that when somebody goes to the browser and clicks on this button, it'll actually launch an integration flow. And then that flow will send a message via RabbitMQ with a token in the header. Now, we have our email controller. It's just an HTTP controller. We're injecting the repository and injecting a message channel called requests. We're also depending on a repository method that we don't have at the moment. So let's go ahead and add this. All right. So now, what are we doing? When we make the call to the via post, we make the call to API/email from the JavaScript code. It has to it's going to send it to the gateway, which is going to have a valid session, which is going to then send a token via token relay filter. That will get here on the resource server, the API itself. And then there's a filter here that will look at the incoming token. And if it's valid, it'll talk to the OAuth authorization server and create a JOT object that we can inject. Ultimately, this is just a thing that we can use to get access to the current token, okay? So I'm going to inject that. This is the authentication principle. I'll inject that, and we'll have a request parameter here for the customer to whom we want to send an email. So we're going to get the current token value. We're going to create a message using the message filter, passing in a reference to the customer ID, the customer itself. We're going to create a header called JWT, passing in this token, and then we're going to send the message out on this channel with the message in with the header and with the message and the header. And then we're going to return to the client, the browser client, a JSON stanza that has an attribute called sent and another one called customer ID. Now, the question, of course, comes up, where is this message channel? Who defines this? What is this? Well, this message channel is a Spring Framework message channel. It's a pipe, basically. It's a queue. You put a message in, it pops out the other side for something else to consume. And we're going to define that here. Here's the integration flow. We inject the message channel for the requests and an AMQP template, allowing us to easily send messages via the AMQP protocol to RabbitMQ. And the flow is basically a message comes into the channel, it pops out the other side, where this integration flow picks it up. It transforms it from a Java object, remember it's a customer, into JSON. And then the JSON string gets sent out via this outbound adapter to RabbitMQ. And it gets sent to this destination in RabbitMQ called emails. Okay, so that's all we need for the resource server. Let's go ahead and restart this. Okay, so now that's running. Now we need a processor, something that's going to consume that message and then do the validation. So we'll return to our second favorite place on the internet, start.spring.io. And here, we'll create a new module called processor. It's going to be using Java 21, Gradle, who cares. We're going to add the AMQP support for RabbitMQ, Spring integration, the web support, although we're going to change that to be just JSON, the OAuth to resource server support, the security support, and then we're done. Let's hit generate. We're going to unzip processor, move processor into our system, and we'll just re-import that here. Okay, so this is going to be an integration flow that deals with the incoming RabbitMQ message and the authorization server. We're going to create an integration flow and add some security filters to protect that flow from getting messages that are not authorized. All right, I've pasted this in. Let's go through the top and we'll review. So first thing first, I've got a little class to stash some important, well-known names that will be used frequently. First of all, the name of the RabbitMQ destination is called emails, and the header that we're looking for that contains our JOT token, our JBC token, is this one here. Okay, so the first things first, integration flow. This is the thing that looks for messages coming in out of RabbitMQ, and they come from RabbitMQ, they get sent into this channel that we've got on the consumer side here called requests. That channel is defined here. And that channel is injecting something called a JOT authentication provider. It's a direct channel. It's a Spring integration, Spring Framework messaging channel, but it has some filters, some interceptors that are going to enrich the messages that pass through this channel. And the first thing we're going to do is use the JOT authentication interceptor. What this is going to do is it's going to look for a given header name, which in this case is JOT. It's going to get the authentication provider, and it's going to create it's going to attempt to authenticate with the value in that header. And if the authentication is authenticated, then it'll create a username, password authentication token and stash it in the header of the message. Otherwise, it'll return null. Okay, that goes from there to the security context channel interceptor. Well, of course, it knows about the same header. So the output of this is going to be a message with a valid header or null. And then that's going to pass to the Spring Framework security context channel interceptor. And this is going to, in turn, get the current security context holder. This is a singleton that Spring Security knows to use to look for the current authenticated user. It's a thread local in effect. It's going to take that value in the header and then, stash it in the security context, which is what all the Spring security infrastructure, the filters, all that stuff knows to look at for the current user. Once that's done, it's going to then send it onward to the authorization channel interceptor. And here, we're going to take the current message and we're going to do an authorization decision, checking the current authentication to make sure it's valid. And this, behind the scenes, is going to use the OAuth resource server issuer URI, right? Because we're going to configure this as kind of a resource server without an HTTP endpoint. So it's going to talk to the same OAuth authorization server issuer URI as the HTTP gateway did before, and the resource server as well. So if all that goes correctly and it's got a valid, if it's authorized, then the message will go through the channel and pop out the other end, where it'll then arrive here in the second integration flow. So we have one integration flow to pluck the message from RabbitMQ, gets funneled into a channel, and then if it's successful, it gets popped through the channel, and then we get to pop it off that message channel, and then just in this case, print it out. We're not actually going to send an email, but you could. There's a lot of easy support for Spring and Java Mail and SendGrid and all that. Okay, so we have a very simple flow, but you can see this is the key stuff here. Two of these are provided out of the box, right? It's this first one that we had to write ourselves. It's a simple channel interceptor. And the only reason we care about this is because we want some way of getting the string, that Spring Security, getting the string and putting it in a place where Spring Security would know to look for it, and then it can handle the rest of the process of taking the value, turning it into authentication, and then using the authentication to actually do authorization. So with that, we have our consumer. This is the processor. Now we have to go back to the build here, build.gradle in the processor. Remember, we're not going to use web because we're not a web server. This is headless, so to speak. It's just JSON. So we're going to import that. And of course, this is still going to talk to RabbitMQ, and it's going to talk to the OAuth authorization server, which is the issuer URI. So we need to configure all that. Okay, paste that in there. Same as before, localhost 8080, user and password. Okay, let's start our processor. So now if everything has gone to plan, we should be able to see in the processor some output whenever we send a request by clicking on the email button in the UI. Let's try it. Hey. Okay, so we're back to this. We're going to click on a button, let's say for Josh. Go to the processor, and there we go. The ID of the authenticated user, the customer rather, the ID of the customer is 20. The name is Josh Long, and email is this. And of course, who is it for? Well, it's for this principal called 1. The credentials are, of course, obfuscated. It's authenticated, so it's true, etc. So we're using OAuth in this processor module, which is not connected to an HTTP server at all, to validate that this message has a right to be sent. And if it didn't have a right, then we would never have gotten this message. It would never have been printed out in the first place. All right, so that's pretty easy, right? Now we've looked at how to use JavaScript and static CDN-hosted single-page apps with our authorization server, and we've looked at how to host and secure back-office messaging flows with our authorization server.